Hi, good afternoon, everyone, dear authors and invited guests. It's my great pleasure today to welcome you to the Sixth International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and the Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID 19, we wish everyone and their families a safe time. And for sure, we will all together pass through this very soon. Further, the good news that with immense happiness that I would like to share you that we have received overwhelming response this year across 90 countries, 1,150 papers. Among them, 350 were accepted to contribute to this conference. So those papers will be published on the next 4 volumes for sure this year. Dear participants, authors, and guests,
Feroz, you have been muted. Sorry.
I'm really sorry. I'm really sorry. Okay. I will repeat again. I'm really sorry. So, good afternoon, dear authors and invited guests. It's my pleasure today to welcome you to the Sixth International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and the Global Knowledge and Research Foundation. As every one of us is passing through unseen circumstances due to COVID 19, we wish everyone and their families a safe time. And for sure, we will all together pass through this hard situation very soon. Further, with immense happiness, I would like to share that this year we have received overwhelming response over across 90 countries and 1,150 papers for participations. 350 of them were accepted, and the success papers will be published in the next 4 volumes this year. We are thankful to all of our guests and participants to show and present their research over this digital conference and digital platform. Even again, that we are all passing through dramatical circumstances due to COVID 19, your attendance and participation will make this conference fruitful in terms of technical knowledge, and we hope that you will all enjoy the next couple of days and to have an interactive sessions. Now, I would like to welcome you to the technical session number 1A and further to introduce you to the chair of our session, Dr. Mufti Muhammad. The profile is rich, so I wanted to summarize it, even that every single word is worth to be mentioned again and again. Dr. Mufti Muhammad is a senior lecturer of computer science at the School of Science and Technology. Dr. Muhammad leads MSc in data science for business data and the data analytics standard in the online courses. Dr. Muhammad is also a member of NTU Distance Learning Governance, Operating and Steering Committee, as well as the International Mobility Committee. Dr. Muhammad is highly experienced in blended learning and online learning in higher education. He has 7 years of experience. He has several years of experience in developing content of asynchronous learning on postgraduate, mainly level 7 courses that is mainly focused on big data analytics and machine learning. As a competent educator and frequent speaker in events with heterogeneous attendance, Dr. Muhammad is well versed in teaching technical subjects for those who are not coming from technical backgrounds like business administration students and students who are applying for computer science converging courses. Dr. Muhammad is also heavily involved in organizing conferences such as the coordination of the local organization committee chair of the IEEE World Congress on Computeral Intelligence, held in Glasgow last year. So thank you, Dr. Mufti, for being the chair of this session and for giving me the chance to introduce you and your rich profile. Heading from there, I want to just to make a short reminder about the rules of this session. The participants are kindly requested to be muted unless it's the presentation of the participant. Each one of the participant will have 15 minutes. At the 10-minute, I will raise a soft reminder that we are almost there. At the 12 minutes, we will, sorry, we will have the questions and the answers from the chair. And for sure that we have many questions, so you can push them to the chat as well. For now, I will start with the first paper. It's my pleasure to welcome Dr. Mariathio Treshan. I'm sorry if I'm spelling the name incorrectly. And on behalf of the co-authors, to present the paper, Systematic Literature Review of Essential Enterprise Architecture Management Dimension.
Thank you,
So
Chair.
the mic is yours, Doctor.
Correction, not yet a doctor.
Okay.
I'm just sharing. Chair, if you can let me know when you see my presentation.
Yeah, we can see it.
Okay, perfect. So, very good afternoon, good morning, good evening to everyone. I'm very excited to have this opportunity today to be able to virtually present to you my findings from my study, which was a systematic literature review of essential enterprise architecture management dimensions. My name is Trishan Marimuthu, and just to tell you a little bit more about myself, I'm a PhD student under the supervision of Professor Alta van der Merwe and Professor Arona Gerber, and I'm registered at the University of Pretoria in South Africa. This study formed the first part of my research, which followed a design science approach in the field of enterprise architecture. All right, so huge investments are continually being made to increase organizations' effectiveness and efficiency, and technology is a big part of this investment. Yet many organizations consistently find it challenging to bring strategy to execution. Now, enterprise architecture is generally believed to be the solution that aligns business and IT strategy. And while many organizations make substantial efforts to implement EA, they neglect in the efforts required to follow through with aspects related with enterprise architecture management. Now, if EA is recognized as the accepted solution by organizations to assist with strategic transformation, then why is there no commonly accepted understanding for maturing enterprise architecture management? Well, one of the reasons for this is the lack of agreement in what should be the key focus areas once it's implemented. Now, research has provided many different frameworks and methodologies, but they all have a very generalized view and often needs to be customized in order to meet the organization's objectives. Preliminary investigation suggests that there's little research in the area of EAM maturity, and we cannot attempt to understand how to mature EAM without understanding the different dimensions that are and their links to existing frameworks, as well as the implications to people, process, and technology. For the purpose of this study, an EAM dimension was described as a measurable component of enterprise architecture that could have different maturity levels of associations. And once we have this, we can then determine what's the must-haves from the nice-to-haves. We're definitely seeing an increasing number of studies, which then speaks to the importance of EA, but there's very little information on the dimensions of EAM and how to mature them. There's plenty of good literature when it comes to guidelines for implementation, but what's required is the next level intervention that would separate these dimensions to what contributes to success and what provides little to no value. And that has been the objectives of this systematic literature review, with the hope of creating a baseline that can be critiqued and improved with further studies. It's important to then understand why organizations need enterprise architecture. And this statement for me explains it very concisely, as it speaks about positioning the new development within the context of existing processes, IT systems or technologies, and people in order to support the change. Now, most industries still find it challenging to manage EA once implemented, and these challenges that impede enterprise architecture includes aspects such as unclear roles and responsibilities, ineffective communication and adoption, the socio-technological literacy, the lack of process integration, and that's just naming a few. What we need to understand is that the concept of enterprise architecture is far more than just modeling. A big part of it includes management of tasks related to planning and executing business change from an architectural standpoint. Enterprise architecture management has many dimensions, but not all of them are relevant to all organizations. So it becomes important to understand which dimension is pertinent to one's objectives. And this is key for EAM success. There's been a strong association with EAM as part of an enterprise architecture project, which then suggests that there's a beginning and there's an end to EA, but there's another aspect of EA which relates to the continuous management of functions and other relationships of EA after implementation. To fulfill this objective for this study, the approach as described by Oakley and Shabram was followed. Using the steps set out within the phases, a protocol was developed and then tested before starting the official study. These steps that was followed can be seen in the presentation in front of you, as well as it's further detailed in the paper that is submitted. The research search criteria itself was executed against 6 databases, and it yielded about 618 studies. After applying the exclusion and inclusion criteria, as well as the quality management appraisals, the study was left with 45 quality studies that was left to conduct the research. This data was then analyzed and synthesized using software known as Atlas TI. And while many conclusions were extracted through the synthesis of the study, there was definitely no consensus on what the exhaustive list of essential dimensions were. Many of these dimensions had direct and indirect implications to one another, as seen in the relationship diagram in front of you. But some dimensions definitely stood out in literature more than others. And a good example of this was integration. And we'll go into that a little bit more detail later. Once these dimensions were identified, each dimension was classified into related themes. And these themes later became known as enterprise architecture agenda, compliance, enablement, and transition. And over the next few slides, I'll provide a few insights that stood out within each of these areas. The agenda theme focused more on the foundational elements. And when we start looking at the detail, we can definitely see huge spectrums of dimensions fitting into this theme. Principles, frameworks, domain architecture deliverables were all strongly evident. But skills had the strongest focus, with it not being enough to just have one architectural domain experience, but cross-cutting into one or more of the other architectural areas. Enterprise architecture mandate also featured very prominently, with it being unclear when it comes to how decisions are made and what are the processes that needed to be followed. And this ultimately resulted in organizations not making use of the services, which led to the failure of the practice. Enterprise architecture management methodology was also highly featured, with the poor implementation of the methodologies, with reasonings being no alignment or adaptation into existing methodologies within the organizations. I think it's important to understand that these methodologies that exist are mere guidelines and not prescription. And without understanding that, it's detrimental to the practice. Within the compliance theme, a little bit more insights into some of the less prominent detail of governance implications surfaced. Some of these lower level implications related to enterprise architecture management goals alignment, policy enforcement, as well as process integration. There was strong focus on integration between the different areas of organizations and enterprise architecture management. It wasn't enough just to create principles, standards, and policies. Adoption needed to be increased through awareness and socialization. And while governance assisted with the communication of EAM artifacts amongst different stakeholders, this form of communication ensured compliance and alignment between certain areas of business and IT and lacked in the areas that fell outside of his reach. Within the enablement theme, which related to how do we make use of the information once we gather them, there's definitely been a mindset shift from entry-level platforms and applications such as Excel sheets and modeling tools to more insight-driven tools. Making information that is already available to those who require it is fundamental to EAM success. There's no benefit to putting that effort into recording and documenting architectural information if it's not available for use. And in the same way, developing fit-for-purpose documentation was key. Compiling a 150-page document that only a few could understand was not enough. Making use of these documents became critical. Finding the balance between relevant information and stakeholders is key to this.
Okay, sorry for interruption, but we are almost there and we have to go to questions and answers.
Okay.
Yeah.
Can I continue?
Yeah, in brief, you have less than 1 minute.
Okay. In the transitional phase, the dimension that assisted with the execution and continuous improvement were evident. As with the compliance theme, stakeholder management was important in this dimension. Understanding hierarchy and their needs was also highlighted as a concern. It's necessary for stakeholders to provide the needs for the stakeholders while still providing the value from EA. Change management was also highlighted as a concern, and tied to change management was communication, with specific focus around shared dictionary and marketing of these services.
Okay, so yeah, could you please just brief, because we have already delayed, and let's go to the questions and answers.
Sure, no problem.
Okay, Trishan, thank you very much. I think, well, it's actually an important, very important field, which still needs a lot of exploration. So I just have one quick question, which is, well, you can also consider it as a curiosity rather than question, actually. So that is, did you find in your literature search that you have done any domain-specific changes in the analysis of the requirements in this particular case?
Yeah, so not so much as a change, Chair. So there's definitely a growth in terms of technology architectural domain. We're seeing more evidence of security architecture being introduced into that with the later involvements of EA looking at innovation. That's also something that's going to probably come in the future. But the technology aspect, the architecture domain aspect of it is definitely growing. Technology in itself is just too large to have one domain to assist it, if you understand what I'm saying.
So, well, related to that, let's say that if I would like to, for example, apply in different fields here, for example, well, taking into consideration healthcare as a field and in other probably business as a field as well, because those are getting more increasingly involved in the automation process, and gradually we are probably moving towards that era where all these services will be delivered through online provisions. So from that particular perspective, do you see any changes or anything that might dictate the governance of these architectures in the future?
Definitely. So in terms of the four elements, and I'm gonna make reference to the four main elements, which is business, application, information, and technology architecture. And I spoke a little bit of the growth of technology and the involvement of technology in it. But I think another big aspect, enterprise architecture is shifting from more of a information management system to a strategic alignment strategy. So we're seeing more involvement from a business architecture side linking to the strategy side, more involvement. There's a lot of new frameworks that came out, which is known as the EA Guild, which then looks at how do we tie in business architecture with the strategic elements of the organization that's currently in place. So there's a different shift from in enterprise architecture from where it was, which was just managing information systems, to how do we tie it tightly with strategy and assist with the transformation that is required.
Excellent. Thank you. Thank you very much for your explanation. And if there are any other questions from the audience, it will be the time we may take one question from the audience, please.
Okay. Maybe the audience prefer to shift their questions till several minutes after that. So now let's get back, if you please, to the presentations and move to the next presentation.
So thank you very much, Trishan.
Yeah,
thank you for your time.
For the great presentation and the great ideas. So now, could you please allow me to introduce Carolita Marcos, who's the author of an interesting paper which meets the recent trends in the market, artificial intelligence edge and applications in 5G networks. So the floor is yours, Carolita, and we are all listening and enjoying the presentation.
Just 1 second.
Hello.
Here, I think that, well, in between there were a couple of other papers, but are the presenters of those papers available here?
Unfortunately, the presenters are not there. That's why
I'm not here. Okay.
Yeah.
So because I see that there is a paper called Behavioral Analysis of Wireless Channels Under Small Scale Fading by Mridu Lakode.
Yeah, it's
yes, sir. So that presenter was not here, but so we are skipping right now that paper. So if they join later on, we will give them chance to present their paper.
Excellent, right? Excellent, yeah. Excellent.
Yeah. So yeah.
Okay, can you see my screen?
Yeah, we can see the screen.
Okay, let me switch. Okay, welcome. I'm Carlota Villasante Marcos. I'm working right now as a data scientist in Ericsson R&D in Madrid, in Spain, and I'm going to present you my paper that is titled Artificial Intelligence Edge Applications in 5G Networks. This is the agenda for the paper presentation, and I will start with a bit of background. Sorry? I think
please,
there's
you
someone.
can continue. Yeah, you can continue, please, Carlota.
Can you hear me?
Yes, we can hear you. Please continue.
Yes, but your screen has been unshared. So will you please share your screen again?
Yes, of course.
Yeah, thank you.
Okay.
Excellent. Yes.
Okay. So let me continue. This is the background. I think it is really important to know that nowadays we can find computer vision, that it is an artificial intelligence technique that can perform image recognition and classification, object detection. We can find it in some real examples like self-driving cars. We can find it in health diagnostics, surveillance cameras, but some of them, or most of them, they need this dedicated hardware and software. They need this heavy machinery, and because of this, they have this reduced mobility or lack of mobility. So with these new technologies that we have right now, like 5G, like edge computing, why don't we do this computing offload of these technologies in order to have lighter, simple, and cheaper devices, to have a centralized solution so we can distribute these applications in order to have different end users doing these recognitions and these computer visions, and to have and to rely the intelligence of the applications into the network. So during this study, what I did is to investigate how to rely this computer vision, connect them, and get advantage of this 5G, new 5G network. This fifth generation, what it does is it is managed that it will give us more mobility, it will give us less latency in order to have fastest communications, and it will give us more user experience data rates. It is also occurred in the ITOR 2083 that these kind of use cases will be on the ultra reliable and low latency communications. So this project, what we did in this project in order to present this paper? We created a computer vision model in order to see how can we rely with these applications and to put it in a server, and an offload server, in order to manage end user equipments with this over this 5G network. This project was under the scope of the 5G EVE project, that it is a European project, and it was done in Madrid, as one of the laboratories of these projects. It's in Madrid in Five Tonic. This investigation was done within Ericsson, that provided all the infrastructure in order to do the analysis. So what we wanted to see here, if it's possible, the feasibility of using this computer vision with image recognitions use cases. It could be on a droid, it could be on a robot, it could be in any device that can have mobility, but with this 5G network. So let me share the pointer. This model, what it does is that we have an end user that it's providing a video, and then it's streaming this video to a server that is located in other premises. It does this object detection. It is done with a neural net in order to see what objects does the end user can detect, and it creates a control command in order to send it back to the end user. So in order to do the study, we did a comparison with 4G and the possible scenarios that we can find in real life. Here you can find some examples of this computer vision model. Here you can see that there are some projects ongoing with intelligent scanners in order to see if there are no errors on manufacturing. Here we can see an AGV, automated gated vehicle, and if we put this computer vision model on top of it, it will recognize the objects that are on the laboratory, or in order to in other premises, it could find if it has to catch one object, if it is on one chair, or if it is on a table. And also this model could be used on drones.
So dear, we have 2 minutes.
Okay, so the environment and the location, as I said before, it is in 5 tonic in 5G, and we use the run of this laboratory. where you can see that it was with 4G, 5G NSA and narrowband IoT access. It is done in order to have this uplink traffic prioritized with a TDD pattern of 7.3. And we used a Raspberry Pi and 5G CPE in order to do the connection. So we did some measurements here. In order to do this, we have the scenarios. In 5G, we have the edge scenario that it's near the user. And in 4G and 5G, we have the regionals that it's 200 kilometers and the national that it's 400 kilometers. In order to do all these measurements, it's really important to have some lag synchronization. And this is important because we have to take some measurements from the UE, the packet core, and the application server. In order to do it real, we did some comparisons in different codecs and in different email resolutions. For the measurements, we did the latency. That is really important for 5G networks. We measured the end-to-end latency, the one-way, just from the UE to the server, and the end-to-end service response time. That here it's like the new thing that we introduced. We have the end-to-end, but we have to take into consideration the processing time. And this use case is really important because we have to consider a complete video frame. Okay, so it's a lot of packets. Here, yes, here we can see that the 5G edge scenario is the fastest one in the latency. Okay, and it is all 5G scenarios are below the 4G measurements. It is really important to know that we have uplink traffic because it's the video being shared from the UE to the server. And we can see that all the resolutions have more or less the same latency. For the error propagations, we can see that it's negligible because it's less than 1 milliseconds, and it's not comparable with all the end-to-end service response time that it's 87 milliseconds. Here we measured all the processing time, that it's all the activities being done in the computer vision application server. Just to finish, one thing that sorry, just the last thing that we did is the availability and reliability and mobility is really important in this kind of measurements. And we had another approach where we set a limit in order to have the reliability to calculate the latency and the velocity. And we can see that the 5G edge one, it's the fastest one and will give us more mobility for these user equipments. Just to finish here, what we saw is that the latency is lower in 5G versus 4G. It is really important to focus the use case. This is a model what we presented, but it has to be focused later on in every use case that we can see in here in the world. Okay.
Okay. So thank you
very much.
Thank you for the great presentation and the great idea. Also, the efforts are very clear. Now we will get back to Dr. Muhammad and to listen to the questions that he would like to discuss with you.
So thank you very much, Carlota, for the nice presentation. Well, indeed, we are moving towards automatizing the systems in portable devices, and that is something which is going to be very, very, very interesting from the application perspective as well. Now, the applications that you have presented all are beautiful. Yeah, they are in real life, and that is what we really need. And it has got not only those, many other applications, for example, disaster management and providing support to the people in distress when there are natural disasters and etc. So taking all this into consideration, right now I have seen that the system works very well with video data. Yeah. However, taking one step ahead, yeah, given that right now the processing, the AI part is carried out in the server, yeah. So if you'd like to bring it one step closer, so because you talked about edge, so if you'd like to perform the analysis or the processing of the video at the edge itself, so what do you think are the main challenges and how those challenges can be overcome?
Yes, of course. Well, the processing of this server, the server in the edge scenario that where we tested, it's to be near the user equipment in a range of 0 kilometers. Okay. Then we also tested on a regional and a national scenario. But it is really important to have this connection, this 5G connection that will that give us a low latency. Okay. But it's also really important to have good equipment. I mean, it is really important to have an equipment that will give us velocity and will give us this computer processing good and in time.
Yes, well, that is something which is nice from the processing of the server perspective. But let's say that when we are talking about edge computing, because edge sometimes is actually a terminology which is defined differently by different companies. For example, Cisco defines edge in one way, and the other companies probably defines edge computing in another way. So let's say that if you would like to, given that, well, drone sometimes can actually have a number of processors mounted into it and can have some processing power on itself. So do you think that the technology can actually push towards doing on board analysis or processing of the video on the drone itself, and then only provide the necessary actions to the servers for further processing or further action? What is your idea about that?
Well, if we do this video processing on the drone itself, it will need some hardware and software dedicated. So this could be the drone itself. It maybe need to be huge in order to have CPUs and GPUs in order to do this processing, and also it will cost a lot of money. So if we do all of this processing in the drone itself, maybe it won't be used from so many enterprises, or it could not be used by some people that do not have these resources, you know? So it is really important to know which kind of options we have. Of course, we can do it in the user equipment itself, but this implies that you need money in order to have this hardware and this software. But there's the other option. In order to do this computing offload to the network, where you can have a droid with a SIM in order to do this communication, send this video, and do all this processing in other location. It could be in your enterprise, it could be in your garden, but it is more easier and it is cheaper. So you can have a drone that it is less complicated itself, but you need this communication with the server. Of course, it could be done. It is not nothing impossible, but it's something to consider.
Okay, just well, thank you very much for the answer. Well, just one point of probably suggestion is for the future, if you consider, let's say, mounting a couple of Raspberry Pis on your drone itself, probably because Raspberry Pis are powerful. Yeah, they do not need a lot of space. They are not very heavy, so drones can very easily fly them off without any difficulty. So probably, well, if you can implement few models on the Raspberry Pi itself, it can probably provide implementation on site, yeah, on the drone itself, and then just send some notification. Okay, so thank you very much, Carlota, for the nice presentation. Yeah, so let's move to the next one. To you, Fairoz.
Yeah, sure. Thank you again for the great presentation, and all of us are curious about the future of the 5G. So now, before moving to the next presentation, it's kindly requested to rename your title that shows in Zoom if it's not exactly the same that is presented on the presentation. For not interrupting you, I will use this poll. Just raise it when the time is almost over, so it will help me to make you continue the presentation. And now we will go to the next presentation with Master Lim on behalf of the co-authors, who will present us a review How does ITC affect the health and well-being of teenagers in developing countries? So the mic is yours and we are all listening. Master Lim, are you with us? Okay, so
Excuse me, can I see the screen now?
yeah. Is there any technical limitation? To share the
Can
screen,
you
just
see the screen now?
yeah, no, we can't see it. Just press on the green button in the middle of the below bar. It may take several minutes. It's a second, sorry. If there is any warning message, just click OK to stop the sharing from my side.
Yes, Vilona, can you hear us? Might be he is facing some technical issues. So
Yeah,
so,
By any chance,
yes, Mufti sir, should we
yeah,
go ahead with the next presentation?
yes, by any chance, well, will it be possible for you to email the presentation to any of the organizers? Okay, so we can accommodate, or we can share our screen, and then you will be able to present. So that is also a possibility. So in the meanwhile, let's go ahead with the next speaker, and then
Yeah.
well, if any of us, I'm going to share my email, or if Fairoz or Mihir is going to share their emails,
Yeah,
that is
sure.
absolutely okay. Anyone can receive that presentation, and then we can share our screen without much difficulty. Yeah.
yeah,
So
for
let's
sure.
go ahead with the next one, and in the meanwhile, we will be getting the presentation from Wilone. Thank you very much. Yeah.
Okay, so for the next presentation, we are sorry for the short notice, but it's for Dr. Or Mr. Driss Kububu on present on behalf of the co-authors of the article that is titled as Construction of Some Good Binary Linear Codes Using had a mark matrix and BCH code. So could you please start the presentation?
Okay, you hear me?
Yeah, we can hear you clearly.
Nice. Just a moment to share my presentation.
Yeah.
Excellent. We can see it. Please go ahead.
Okay. Just a minute. Okay. Good afternoon to everyone. I am very happy to be with you today as part of the 6th International Congress in Information and Communication Technology. My name is Driss Khabou, a PhD student at Moulay Ismail University in Morocco. Today, I am going to present my work, and for this, I will proceed according to the following plan. First of all, I will start with an introduction in which I will define the context and the motivation behind this work, and the information theory as seen by the scientist Shannon. I will also describe the error correcting code and their property, and finally the problematics in which our work is focused. Secondly, I describe the error correcting code, especially linear codes and their coding principle. Then presenting our method to build good correcting code from already existing codes with an illustrative example. In the fourth part, I will evoke the results of our method and interpret them. Finally, we will conclude with some ideas for some future reflections. Wireless channel introduce some errors due to the noise and interference or the multi-path effects resulting in the fast fading. There are two options for remedying this type of problems. The first one is to increase the power of transmission, which generates a waste of energy. The second option is to send redundant information, allowing to detect and correct errors. Our work fits into the second option. When the information theory has first been formulated, it was assumed that communication without errors over a noise channel could be only achieved by increasing signal redundancy to infinity. In 1948, the scientist Shannon transformed everything by his theorem and proved that any transmission channel admits a parameter C, called channel capacity, such as for any E greater than 0 or for any R less than C, there is a code with rate R allowing the transmission of a message with bit error rate E, where R is the information length to message length ratio. The purpose of error control coding is to enable the receiver to detect or even correct the errors by introducing some redundancies to information. There are basically two mechanisms for adding redundancy. First one is the block coding. For this type of codes, the message to be sent is segmented in blocks, and each block is coded independently from the other blocks. Opposite to convolutional code, the coding of block depends on an already coded block. In the remainder of this presentation, we will be interested on block codes. The NK domain notation is used to denote an error correcting code, where the K is the dimension, is the number of the bits in the information sequence to be sent. In the other words, the number of symbols in the block to be coded. Length N is the size of the message to be transmitted after adding redundant parts. The message is called code word. Minimum homing distance domain is one of the most interesting parameters in codes. It is the minimum value in the set of homing distance between each two code words to ensure that noise does not transform one value to another valid information. Moreover, the ability to detect and correct errors is calculated using this property. The computation of the minimum distance remains an open NP-hard problem in coding theory, especially for large dimensions. So it is difficult to explicitly construct a code with large minimum distance. The coded information block or code word is n symbols can take 2 power n possible values. From that, we select 2 power k code words to form the code. A block code is said to be useful when there is one-to-one mapping between information block M and its code word C as shown in the figure above. An encoder generates a message of n coded bits from k information bits, and we call this as nk block codes. The coded bits are also called as code words in the set of 2 power k code words. If the sum of any 2 code words is also code word, the code is called linear block code. All code words of the code can be obtained as linear combination of basis vector of the vectorial subspace of 2 power k code words. The basis vector G can be designated as G1, G2 to Gk vectors. For a linear code, we can find a k by n generator matrix such as a code word C can be obtained by the formula below. The vector, the code word C with length n is equal to the product between the information vector with the dimension n by the generator matrix with k rows and n columns. Our solution or our method, our proposed method, proposed to build some good binary linear code from already existing codes, especially BCH code, which are of considerable importance of error correction, and the square matrix of order m, with m being a power of 2, and entries in +1 and -1 called Hadamard matrix and obtained by the formula below. But for information, in the binary case, +1 can be replaced by 0 and -1 can be replaced by 1. The first step for our method to construct a good binary linear code is to extract a redundant matrix P from the generator matrix G of a chosen BCH code. P is the parity responsible for redundancy added to information B. The second step is to perform the canonical product between P and Hadamard matrix of order 2. The second step is to parse the results of step 2 so that the weight of each row is greater than or equal to the lower bound, where the lower bound is the experimental minimum distance achieved to date for the parameters n prime and k prime of the code we are trying to build. The fourth step is to construct from results of step 3 matrix by combining k prime rows, where k prime rows is the desired dimension of the code we are trying to build. In the fifth part, for its matrix from step 4, we construct a binary linear code and calculate his minimum distance if it is greater than the lower bound, and add the code to the list of good binary linear codes.
One minute left. Sorry for interruption, but we have 1 minute left.
Okay. Let's take a for example, let's take a generator matrix of BCH code in the systematic form to separate information bit redundant bits. And let's take A, the result of the canonical product between redundant part and Hadamard matrix of order 2. By definition, the minimum distance of a linear block code is the minimum weight of non-zero code word in the code, where the weight of code word is the number of ones in it. So we must eliminate from A the row whose weight is lower than the lower bound. After filtering and combining k rows, we are able to build two good binary linear code. G1 and G2 have the same parameter, and G3 have another parameters. You can see here all the good code we have been able to build, and almost of them have a minimum distance equal to the best experimental distance achieved to date.
Yeah.
Channel capacity.
Just conclude because our time is almost over. We are sorry for that.
Okay, I will conclude.
Okay.
Channel capacity is one of the most significant parameters of data communication. To take full advantage of the channel capacity, we are often interested on code with rates higher than 0.5. The focus of this work is to illustrate the existence of a way to search for good linear codes from popular code. The exhaustive search becomes impossible from a certain dimension of code, given the limitation of the computer used. Our future vision aims to improve our methodology by taking advantage of the mathematical properties of BCH code on one hand, and by using heuristic algorithms to search on the other for finding high-dimensional code.
Okay.
Thank
so-
you for your attention, and I am very happy to be here today.
Yeah, thank you for the great presentation, great efforts and the idea. And now we will get back to the chair for questions and discussion.
Okay.
Thank you very much, Dries, for the great presentation. Well, I just have one curiosity rather than question, actually. So will you please highlight some of the applications where this new coding would be useful or advancing the communication that we are having right now?
This code could be used in the channel communication to allow the receiver to detect or correct event error due to the noise in a channel communication. So it is planned to do an encoding simulation in an AWGN channel and to test different types of decoding on these new codes to know their adaptability in a communication channel.
Okay, thank you. From that particular perspective, do you think that, well, this will something which will improve the performance of the communication significantly, or what is its effect on the latency of the communication?
The idea is inspired from the most popular codes now is the polar codes. Polar codes have proved that have proved their performance in 5G communication channel. So in our future work is to test our code in a real communication channel to make simulation in a real communication channel in 5G technology.
Okay, fine. Thank you very much. I don't have any further question. Please to you, Fairoz.
Okay, so
Thank you.
thank you again for the nice topic, which is for me very hard, but I'm totally interested in learning more about it in the future. So now we will move to the next slide, the next presenter and another interesting topic. Now we will move to Japan, to Kanihu Takamasu. I'm sorry, I'm pretty sure that I spelled it incorrectly.
Okay.
And on behalf of the co-authors, who will present a new concept of ICT on
Informatics
in
higher education.
Yeah, you see, it's hard to me, but I'm sure that it will be more than interesting. From my side, I will share the slides. Okay, seconds, please. I will share the.
Yeah, I will share.
Okay, I will share the slides. Can you share it from your side? If not, I will share it from my side. Okay. Yeah, brilliant.
Hello everyone. Today I will talk about a new concept of ICT on informatics in higher education. My name is Kunihiko Takamatsu. I collaborate with Ikuhiro Noda, Kenya Bannaka, Tomoe Nakagawa, Yasuhiro Kozaki, Kenchiro Mitsunari, Masato Omori, Ryohei Adachi, Yasuo Nakata. This is the first time our presentation in ICICT. Our main target is education, but there is no target about education in ICICT. So we present our research this track. Today I have 3 topics. The first topic is introduction and my research question. And second topic is 2 practical examples. The third topic is conclusion. Introduction and research question. I think many people know the field of bioinformatics. Bioinformatics is the word or field combination between biology and informatics. Recently, we propose new field, eduinformatics. Eduinformatics is the word combination between education and informatics. This figure shows the concept of eduinformatics. The field of education provides problems to solve to eduinformatics. The field of informatics provides problem-solving method to eduinformatics. This figure shows another concept of eduinformatics. In Japan, education belongs to artistic discipline, and institutional research, statistics, machine learning, evidence-based research, and informatics belongs to scientific discipline. Eduinformatics is interdisciplinary field between artistic discipline and scientific discipline in Japan. Since the early 1990s, many universities in Japan reformed to enhance the quality of higher education. In September 2020, the Subcommittee for University in Japan's Ministry of Education, Culture, Sports, Science, and Technology (MEXT) presented a perspective of the connection between education and research in universities for the future. The proposal stated that faculties of universities have these two features. Faculties in universities are more interested in research than education. And many universities faculty members find it difficult to balance education and research. So, our research set the research question, how to connect education and research in universities to improve the quality in higher education. Two practical examples. We will show the two practical examples in Kobe University. Kobe University and Kobe Tokiwa College located in Japan. First example is this. SWOT analysis and complex network analysis to enhance governance in universities by collaboration between faculty and staff. Main result is to make the universities a better place. It is critical that all faculty and staff are aware of the need for improvement. SWOT analysis is acronym for strengths, weakness, opportunities, and threats, and is structured planning method. This figure shows the final result of this study. In this research, nodes show the opinion, and we constructed edge against every edge. As you can see, B09 is the biggest node. So this figure shows that B09 is the most important opinion. And the opinion of B09 was to make the universities a better place. It is critical that all faculty and staff are aware of the need for improvement. And Kobe Tokyo University decided to make a new project team for university reform under the president. We set the primary goal to build foundation for learning and teaching management for university reform. And we propose integrating accession policy, curriculum policy, and diploma policy. And we make a original student support policy. And to evaluate these policies, we create a common evaluation indicator, so-called Tokiwa competencies. In this research, we define the competencies as this. This definition was defined by Spadi. These figures show the Tokiwa competencies, 9 Tokiwa competencies. In another conference, we present a new way of visualizing curricula using competencies, cosine similarity, multidimensional scaling method, and scatter plotting. Shows a relationship between 14 courses and 9 Tokiwa competencies. In Kobe Tokiwa University, faculty have to show the relationship between courses and Tokiwa competencies in their syllabus. This figure shows the final result in this research. Visualizing curricula using Shirabi using 9 competencies for 40 courses. We describe 2 practical examples. Using these 2 examples, we attempt to answer our research question. First, we recognize to analyze data in eduinformatics, we need to prepare the data. For example, when we obtain student answer from paper questionnaires, we need to type these data into a computer. To obtain significant statistical result, we must use extensive of data. And this is time consuming. However, when we use ICT to collect the answer, for example, Google Forms, it is easy to obtain the digital summary. This is easy since most students in Japanese universities now have smartphones. And we can use the text mining method. So, when we obtain answers of descriptive type questionnaires using ICT, we can use text mining analysis and visualize by networks. This figure shows a new concept of ICT on eduinformatics in higher education. So we propose a new concept of ICT on eduinformatics in higher education. Educational faculty can use ICT to combine research and education to obtain data and analyze them using eduinformatics. This type of research is usually called educational research in higher education. It is an effective method in enabling educational faculty member to perform research activities.
Sorry for interruption, but we have
our research question is
so could you please
how to connect education and research in universities to improve the quality in higher education. And one of the answers is ICT. When educational faculty use ICT to obtain student data, they can easily prepare and analyze these data to enhance the quality of higher education. Thank you for your attention.
So thank you very much for the great presentation, great efforts. And now we are getting back to our chair for the questions and notes. Thank you again. Okay, Dr. Mufti.
Thank you. Yeah, thank you very much. Well, I think that the topic is very interesting, and this is the time that we actually need to focus on, let's say, modernizing our education, and that is something which is really needed in terms of, let's say, providing smart services to the students. Now that, well, we also have tried almost a year of online education, yeah, around the world due to this COVID pandemic. I think that, well, this is the time we need to think about the next generation educational services. So from that particular perspective, how do you think that artificial intelligence as itself as a service can facilitate the edu informatics framework that you have provided here?
Yes, already we predict the dropout student using artificial intelligence, for example, the random forest or some things, and already we get a good result. So in the future, we will show the good result in the next year. Yeah, thank you very much.
Okay, so related to that, what are the specific parameters that you are considering in evaluating the student engagement? Or because, well, you said that you are planning to predict the dropout. So what are the specific parameters that you are taking into consideration when you are predicting the dropout?
So in my case, the data of the collect, the IL team collects the almost student data. For example, the GPA or some things, or attendance or some things, and using more than 1,000 data each student, we use this data. Okay.
So what, for example, so when you say 1,000, are the 1,000 number of students, or
no,
are there
1,000 items for each student?
Okay,
very big data.
Right. So can you please tabulate or tell us the leading 4 or 5 items which are really contributing in deciding this particular classification or prediction?
Yeah, just prediction, because so first we find out the usually many people want to know the good items or good some strong items against the dropout. But we think we can't find out these good classifications or good strong relationships between some items to drop out. So now only we just predict the dropout. So there is no strong items, very weak, but the combination of the combination is very important for prediction in our result.
Okay, so in that particular case, actually, you are using all 1,000 items from each student to predict. Okay. So thank you very much.
Thank you very much.
Kuni Hiko, and well, I again go back to Fairoz for the next one, please.
Thank you very much. See you.
Thank you again for the informative efforts and the great presentation, the great questions as well. So now we will move to the next presentation, which is mainly from France and Lebanon, and it's one of the positive sides of COVID-19. In the past, we used to travel to one place to attend a conference, but now we have the chance to visit all over the world in several minutes. So our next presenter would be Mr. Hassan Shreem, who is presenting the paper titled "A Higher Order Mode Tri-Brand Stacked Patched Antenna for Mobile Wi-Fi and the Bluetooth Jamming Application," on behalf of the co-authors of the article. So the mic is yours, Mr. Hassan, and we are all listening.
Okay, hello everyone. Everyone is listening to me?
Yeah, we can hear you clearly.
Yes, we can hear you. Yeah.
Can you share the screen, or do you want me to help in?
Yes, I'm gonna share my screen.
Yeah, please.
Okay. Just 2 seconds because I did it just before. Okay. Google Drive. Oh, there's a problem. I cannot share my screen actually.
Okay, I will do it from my side. Seconds, please.
Yeah.
Yeah, seconds, please. I will share it from my side.
Please share a screen now.
Can you?
Well, actually, just a second.
It's fine. I can do it from my side. It's already there. So here we go.
Okay. Thank you. Thank you very much. So yes, thank you, Fairuz. So yeah, you will be my my co-pilot to this. So thanks to everyone. I'm so pleased to present to you the work that we have done. It was a collaboration between Dassault Systèmes in France and Saint Joseph University in Lebanon. So I'd like to thank, before beginning, my co-writers, Dr. Ryan Mina and Dr. George Nashif, for this great work that we have done, as you said, Fairuz, between countries without even seeing each other. So yeah, next slide, please. Okay, so just a little bit of summary for our presentation. So I'm going to tell you a little bit about the context of this work. Then I'm going to get into the antenna design, the 3D simulation software that we have used in order to get our results. And of course, finally, I'm going to show you the results, and we will conclude and tell you a little bit about the perspectives. Okay, so basically the context of this antenna lies within the design of a device which is dedicated for jamming application, aiming the frequency band of GSM, Wi-Fi, Bluetooth, and everything. I mean, everything related to mobile phone. So this device is to be placed inside the classroom where you have exams. So basically the final goal of this device is to jam the communication and somehow disable the mobile phones of the students. So what is the role of the antenna in here? Actually, you have the jammer, which is composed by the signal generator, a filter, a mixer in order to modulate the signal. And then, of course, you have a power amplifier, and by the end, the antenna. So today we're going to speak only about the antenna. And we have chosen to use the patch antenna because it's easily we could easily integrate it inside planar devices, such as the one we are talking about. Next slide. Okay, so basically we are aiming for 3 frequency bands, which are around 900 megahertz, 1.8 gigahertz, and 2.4 gigahertz. So basically that's GSM, UMTS, and Wi-Fi Bluetooth bands. So what is the challenge within this structure? Actually, we have 2 challenges. First of all, that we have low frequency separation between the bands. This is from one hand. And from the other hand, we have to obtain, or we have to accomplish a relatively wide matching bandwidth within each band. So basically, the technique we have used is the triple layer stack patch antenna. And of course, we are going to consider the higher modes of each layer of this antenna, okay? But I will give you some details inside. Okay, next slide. Okay, so this is a representation of every layer of the stacked structure, if I may. So as you can see, they represent the name of the university. You have the first patch with the letter U, the second layer with the letter S, and the third and the top, which is the top layer, with the letter J. So if you just go, of course, between each layer, you have we have optimized somehow the permittivities of each substrate in order to get our results. Next slide. Okay. So actually, this stack patch antenna structure, how it works in a nutshell, basically the first layer is excited via the SMA connector, and the second and the third layer are excited by mutual coupling. So basically, we have to optimize everything. We have to optimize, as I said, the permittivity of the material, of the substrates. We have to optimize the position of the slots within each layer. And of course, we optimized as well the position of the SMA connector. So just to give you a little bit how this antenna operates, first you have the U slot, so which is the first layer that, yeah, thank you, which operates at the higher band, which is dedicated for the highest band. Then the S slot is dedicated for the middle band. And of course, the J slot is dedicated to the lower band, which is around 900 megahertz. Next slide, please. Okay, so as I told you, we start with the U shape, with the U slotted patch antenna. Well, this, of course, after a lot of optimization, all the parameters that you could see here on the left, on the right, sorry, they are the parameters that have been optimized. So you have the dimensions of the slot, and of course you have the X feed and the Y feed, which are the position of the SMA connector. So after a lot of the optimization, we have obtained the results that you have to the right, to the left, sorry, of the structure. So you can see the lowest, the lowest resonance around 460 megahertz, and the resonance that is important to us at 2.4 gigahertz, which is very well matched, below -10 decibel. Okay. Within the same, I mean, in the same spirit, we have optimized the S layer. But now what we have done, we started to optimize the first layer, the U. Then we have placed the two layers, the U and the S. And of course, when we have placed the S layer, we have a little bit of, you know, we managed to achieve the matching around 1.8 megahertz, gigahertz, as you can see here on the red curve to the left. However, the you know, the resonance that we had at 2.4 gigahertz was a little bit altered by the presence of the second layer. So if you go, okay, so in the same manner, of course, we have optimized the we have optimized okay, we have optimized the position of the J letter in order to get the lowest resonance at 940 megahertz. So you go to the next slide.
Okay, and we have almost 1 minute and a half.
Yes, I'm done.
Okay.
Okay, so basically we have placed all the patches. So what we have done is that we have configured each patch, each layer differently, but then we have placed them all together, which made the task easier to achieve. I mean, we have optimized each layer alone, and then we have placed them all together, and then we have optimized everything. So if you go to the next slide, please. And just a small 2 words about the 3D solver that we have used. So basically, it's the solver which is called transmission line matrix method, which is a transient solver within the Simula CST tool of the SOSystem. So how it works, actually, each mesh cell is represented by the RLCG network. And by the end, you will obtain a big network for your structure, where you calculate the currents, and the voltages. Okay, and you know, frequency domain results are obtained by a Fourier transform. And the amazing thing about this solver, if you go just back, Fairuz, please, yeah, is that you have the lumping. So here I just showing a small example. If you start by this horn antenna, this is the 3D structure. You have the original mesh on the second picture. On the third picture, the TLM solver does what we call the lumping. So it reduces the number of the mesh cells, and also it distorts the mesh. As you can see here on the zoom, you have meshes that became triangular or trapezoidal. Okay, this is done only to follow the shape of the structure. And there is one good thing about it, is that the final one that I've shown, the final picture, actually is the discretized structure. So basically, it is the structure that have been understood by the solver. So if your discretized structure resembles to the one that you have imported or the one that you have modeled, you can be sure that your results are accurate. And these are the results that we have obtained after optimization. Just to give you a little bit of an example, the structure contained 100 million of the mesh cells. And actually what happened is that after the lumping, we have reduced the number of mesh cells to 250. So we have like 75% of reduction. And the simulation time was around 24 minutes with 150 megabytes of memory. So you can see here that all the frequency band have been matched as
Okay, so thank you very much. We are literally sorry for not going over the whole presentation.
It's okay.
Yes.
And the great of efforts I highly appreciate it, but I'm pretty sure that Dr. Muhammad will give you a feedback that will support you to improve and make it much more informative. So,
Thank
Dr.
you.
Muhammad.
Thank you very much, Hassan. Well, it was a very interesting and realistic, let's say, application, and that is something which in many of the developing countries would really have a good implementation in terms of let's say its applicability. Now, well, just one particular comment from my side, given that we actually do not have much time here. So how would you think that, well, maybe from the application perspective, that how would you think it would be implementable when in cases where there is the necessity of having a Wi-Fi connection, for example, within the network? Well, will the system be allowing selective jamming, or will it be something that requires further consideration?
Yeah, this is a very nice question, actually. The final operation of the device would be like, for example, it will be like a firewall. For example, if you have a Wi-Fi channel that you would like to allow, because you know the Wi-Fi channel is divided into it's divided into many sub-channels. So basically, you can filter the channel that you would like to jam. Okay, but this is done in the signal processing of the device, not from the electromagnetic point of view, if you see.
Exactly. Thank you very much. So that's
you are
all,
so welcome.
Thank you,
guys.
That's all from my side. Yes.
I just have one more thing to say, that this is only the beginning of a project that we will speak with the co-writers, because the next job will be simulating the coverage of the classroom and also simulating the exposure on the human, because you know we have to respect some norms. So there will be there will be some work later on. Thank you very much.
Absolutely, because this is something, as I mentioned, is of a very practical implications and usage in many of the countries, and that is something which will really be interesting to see how it proceeds further. Okay.
Exactly. Thank you very much. Thank you, guys.
Over to you, Fairuz.
Yeah, thank you again. And now we have a chance to go to Russia and listen to the presentation of Ila. Shilob, I'm spelling it Ilya. Yeah, I'm sorry. On behalf of the co-authors, the presentation will be for the paper titled as Multidimensional Blockchain Security Analysis. The mic is yours, and we are all listening.
Thank you. I'll try to be fast. Hello, my name is Ilya. I'm a PhD student at Itmo University, and today I'm going to present you part of my PhD research, which is aimed at creation of new technology which overcomes some problems of ordinary distributed systems. Today I'll cover my technology and then step to its security analysis. It's not a secret that blockchain is not deprived of disadvantages. Significant disadvantage of blockchain is the increase of data storage size. Although attempts to solve such a problem have been taken, in practice, a working solution has not been presented yet. Among most complicated operations is the transmission of data between or data or funds between separate systems. Nowadays, such operations require some solutions like sidechains or attraction of third parties, which actually solves the problem, but only partially. There are other shortcomings like consensus mechanisms, cryptocurrency mechanisms, anti-money laundering, and so on, but I'll not cover them today, as the main target of my research is to solve the main two problems which I have named. I mean, data storage and transmission of data, and to keep main blockchain features like decentralization and resilience against 50% of attackers. So what is multidimensional blockchain? I have never presented it in some English research papers or at some international conferences before. It is a technology which is based on ordinary blockchain, and actually it is a set of blockchains when all blockchains, but first one pass the registration procedure in existing blockchain. Registration means storing information on a genesis block and possibly some other features of blockchain in different blockchain. The structure is presented on the slide. So there are several features like, for example, addressing. Due to registration, it is possible to address blocks, states, users, blockchains, or nodes in the system in the complete system. And also it contains a very important feature, search and verification protocol, which is used in external transaction verification. External transactions are performed in 2 steps. First step is initiating transaction, which is same as ordinary transaction. And the other one uses actually this search and verification protocol. It is searching for the nodes of the originating blockchain and then requests information on existence and validity of the transactions. So about the security analysis. There are 2 main things here. I'll not cover search and verification protocol here, as it is out of scope and it is a rather complicated problem which will be covered in next research. It is already been researched, but I'm not ready to present it here. Here I will present probabilistic and GUC analysis of the multidimensional blockchain itself. From the perspective of probabilistic analysis, there can be 2 main directions for analysis. On one hand, scaling causes change of settings for separate robust distributed ledgers. This causes change of successful attack probability for underlying attacker, who controls constant number of nodes. On the other hand, when we proceed through a registration procedure, the probability of attack for each blockchain depends not only on attacker's actions, but also on probability of breaking security of all ledgers up to the root. So we have to consider that too. The first and the most obvious thing to research here is the evaluation presented by Satoshi Nakamoto in the first work on Bitcoin, and such a thing is done here. So the plot here presents the probability of successful attack depending on number of blockchains in the system. Here I present second probability for registration procedure, as I mentioned before. It is very important to mention that an important shortcoming of Nakamoto security analysis is the absence of a transition delay among the model parameters. Zohara and Sampolinsky evaluated the successful attack probability with this value accounted, and general security requirement is presented in the second row of the table. So it is possible to examine the change of relation between parameters in this equation. And the main conclusion here is that increasing the number of ledgers causes increase of lower bound for the first equation, which might break security for some protocols, which means we have to consider that. Some papers on Bitcoin security are based on the notions of persistence and liveness, and features of blockchain which allow to achieve such qualities. Security analysis of scaling is equivalent to analysis where these requirements are still fulfilled when nodes are split into groups. The core parameter which changes due to scaling is the probability that at least one honest node creates a block in a round. So the value F here. Increasing number of blockchain causes decrease of this probability. The change of this probability strengthens the honest majority requirements. So again, we have to consider that. Final thing about probabilistic analysis is a proof of stake and Byzantium approach. An important proof of stake feature is that it is independent of physical system maintenance. According to the chain selection rule in Ouroboros Genesis, recreation of a correct chain adopted by honest majority is possible from the first block, I mean Genesis block. And the security of the system does not depend on the real number of maintaining blocks, on maintaining nodes, sorry. So I have to hurry. So in case of proof of stake, multidimensional blockchain actually is secure as it does not change the set of nodes required for successful consensus operation. And the same is actually applicable to Byzantium protocols. About GUC security, I'll not cover GUC framework here as I have no time for that. I'll only mention 2 important terms which I use here, multidimensional blockchain and the protocol. Multidimensional blockchain is an ideal functionality which implements the technology which I defined previously. It allows to securely scale ledgers or to perform secure inter-system exchange. And the protocol actually implements it. In my work, I used several models. Examples of these models are presented here. And the main approach, just briefly, is the transition from one model to another. So I sequentially change some parameters of the model and make transitions from one to another. And finally, the final actually part of my work is this slide. These are actually the statements which were proved, which have been proven in my work. And just briefly, they mean that multidimensional blockchain can be used securely to perform data exchange, and actually it helps to perform scaling. So I'll not cover the results as I have no time. Thank you for your attention. And if you have some questions, I would better answer them.
Yeah, so thank you for the great presentation, great efforts, and for sure the answers will come from, the questions will come from Dr. Mufti, who will add a value as usual.
Thank you very much, Ilya. Well, it is actually a very interesting topic, yeah, because blockchain being such a good technology, due to certain limitations that we have not received the amount of attention and implementation it should have received otherwise. So in terms of, let's say, its capability, well, this multidimensional blockchain that you have presented appears promising, yeah. So from that particular perspective, I was wondering that how is the scalability in terms of its processing capabilities, as we are seeing multidimensionality coming into the picture instead of us the traditional consensus-based approaches. So when we have this multidimensionality kicking in, yeah. So how about the processing capabilities of these networks? For example, can we do some sophisticated processing on node to make sure that the capabilities of the blockchains are even more enhanced, or it is only the let's say only the scaling capability of the nodes which will then dictate the more number of nodes being involved, and this is something which will facilitate towards a better secured communication?
Actually, I'm working on implementation of the technology just now. So the research is actually now about implementation. I'm going to cover it in one of next papers, as yes, it is important to show that it is actually thanks to the technology that it is better, not not thanks to the amount of nodes used. Actually, I have shown here that if we use, for example, proof of stake, it is possible to split the nodes into as much groups as we like. So it is possible. And in such case, for example, in our university, there are some works towards using such technologies in Internet of Things, where processing power is quite, modest. So it is important to have some ledgers, some blockchains which can be maintained by just these little small computers. So I think I will show that in one of my future works.
Okay, excellent. Because, well, what from my experience, I have found that, well, the one of the main shortcomings of blockchain technology is its ability to process information in itself. Yeah, so that is something. It will be really very interesting to see that how you are implementing these multidimensional blockchains in this particular regard, and how, if possible, also show a number of different application domains. For example, probably one possible application domain could be securing healthcare data, which is one of the main areas where people are really struggling on transmitting people's sophisticated information. And the other one could be a financial sector, where we definitely would need more secure systems. So yes, it's an interesting work, and there is a lot of prospect if we can bring this technology forward. Thank you very much. Yeah, over to you, Fairoz.
So thank you. I tried to cheat the attendance and let them know who's the next presenter. So now we will get back to Mr. Lim on behalf of the co-authors, and we will enjoy listening to the paper, which is titled as a review: How does ITC affect health and well-being of teenagers in developing countries? So Mr. Lim, I hope that you can share your screen, or if not, I can help you from my side. We are all listening.
Let me try that.
Yeah. If there is an issue, I will try to help you from my side to make it faster.
Yes. Hello, Ilane. You can you hear us?
Can you share my, can you show my screen?
Cyrus, I would request that if you have the slides, please share it from your side so that we can just expedite the process. Yeah, thank you very much.
Can you see it now?
Yes, it is visible.
Okay, so Mr. Lim, we are all listening, and I will help you to move through the slides.
It's okay, I can share it now.
Yeah.
Can you see my screen?
Yeah, we can see it. It's fine. Yeah, the mic is yours.
I'm so sorry about it.
No, it's fine.
Good day, I'm Willie, and today I'm going to talk to you about the impacts of information and communication technology on health and well-being of teenagers in developing countries.
I'm sorry for interrupting you at the very early stage, but there is an echo. Could you please just make sure that the mic is fitted well to the device?
My objective is to try and present both sides of the impacts to you in order to be better educated public on a very important topic regarding teenagers' health and wellness.
Yeah, unfortunately, we can't hear you clearly.
Yes, Vilana, we are not able to hear properly. Can you please check your audio?
The audio from my side, can you hear me? The audio of my side is working, but from Mr. Lim's side, there is an echo.
Is it okay now?
Well, I think that, well, this is actually a problem of the audio device that you are using, because we are experiencing some tunneling effect actually. So what is happening is, like, it appears that, well, you are talking from very far and there is a tunneling effect of your voice. So not everything is understandable. We can definitely hear you, but, well, we cannot understand all the things that you are saying.
So just to save time, please try to disconnect.
Yes,
if it's not working, just go through the slides, and for sure Dr. Mufti and the audience will have the idea about the research.
Yes, Mufti sir. So should we, can we do one thing? We can take a video presentation from him, and that we will put on our website with this. So
that is something
work well.
That is something will be really, really good. I think that, well, just to avoid these technical difficulties that we have, and also let the next sessions which are already on run. So that is something which we probably need to take into consideration. So if let's say that the recorded video presentation is uploaded, that is something will be helpful for all the audience, I think.
Yes.
And definitely, well, if there is anything that as a chair of the session, I can help the speaker later on, or if he wants to have some feedback from me, I will be happy to provide that feedback as well offline.
Yeah, we are sorry for that. And now we come to the end of the session, which was informative and interactive. So at the end of this session, could you, I will, okay. So at the end of this session, I sincerely thank you. I thank all of the authors who are, sorry, could you please just mute? Okay. So at the end of this session, I sincerely thank our authors for the excellent presentations and contribution in this session. All of us enjoyed your participation in the International Congress. We made it come true, and I hope that all sessions were informative and came to the points that really interested for the research that all of us contributing to make it more and more improvement in these hard circumstances. The good news that all participants will receive their digital certification within a couple of business days. So please make sure to check your inbox after a couple of business days again. And the publication, which is our target, will be there within 4 to 6 months. We already communicated the Springer regarding the publication process. So thank you again, and thank you for our chair, Dr. Mufti Muhammad, for the contribution, the added value for each one of the researchers, and to make their work become much more informative and much more meeting the standards and the high quality based on his rich experience. So we are coming to the end, and even though that we are making it virtually, we will have a chance to have a quick picture. So please turn your cameras on and a small screenshot will be a good memory for each one of us. So let's make it like 3, 2, 1, cheers. Okay, so
Excuse me, I have questions.
yeah, for sure.
How about my papers? I didn't present right now.
It's maybe in the next session.
Yes, Mustafa. We have your paper into the next session.
Okay.
So that we will start in a while. Yeah.
Tomorrow.
Yeah, sorry,
sure.
we have a little bit.
So thank you everyone. Let's have one small.
The picture now.
Yeah.
Okay.
One photograph, virtual photograph, and this will share with everyone.
Okay, so allow me to take this opportunity to thank all the authors and the attendees for contributing to this session. And it has been a brilliant session, actually. Well, apart from the technical difficulties that we had, excellent papers, excellent work being presented. Congratulations to all the authors for presenting such nice work here. I really look forward to following up these works and hearing from the authors in the future again. So thank you all. And also the organizers for organizing such a nice conference, yeah, and inviting me to chair this session. Thank you, and stay safe. And probably we will bump into each other in the future in some other conference. Take care. Stay safe. Bye-bye.
Bye-bye. Thank you.
Thank you very much.
Goodbye.
Thank you.